Well, hello there, Science 10. So, I wanted to sit down and talk to you guys a little bit about our naming. And a couple of reminders. One of them is to memorize your diatomic and polyatomic elements. So here is an example of a question where students forgot that sulfur is one of these diatomics. Polyatomics. So it's one of the ones that you have to memorize. A lot of students said, well, sulfur, I just look it up on the periodic table. It's S, it's a solid. Well, unfortunately, that's not correct. It doesn't show you on the periodic table. You actually have to memorize this and know it off by heart. Sulfur has to maintain a full octet to become a stable element by sharing atoms. And there's 8 sulfurs, and it is a solid. Phosphorus is another example. It's P4 solid. And then here's this ozone, what we find in our atmosphere, and that is O3 gas. Okay, so these are ones that you have to memorize. And so a lot of students forgot about that. So I had this little chart for you on your molecular naming booklet. And just a reminder that your diatomics are these guys in red. And so it looks like a hockey stick, an upside down hockey stick. So we've got nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And then here's the puck over here. That's H2, hydrogen gas. Now, don't forget the states are given up here in the legend as well. So these guys in blue are all gases. So N2 gas, O2 gas, F2 gas. Here's the only liquid that is a non-metal, and that's bromine. So bromine is a liquid, not a solid, not a gas. Okay, and then the non-metallic solids, these are the guys in green. And so iodine, phosphorus, sulfur, those guys are all solids. Now your polyatomics, again, they're not written on your periodic table. You have to memorize this. So your polyatomics, P4 and S8, and then of course ozone, as I mentioned already. So many students, you just got to take the time, make a study chart or a card or a flashcard. You can use this, I have no bright or clever friends. That's another way of memorizing it. Okay, so please make sure that you take the time to do that. So I think that students get it. When I give you all ionic compounds, you guys are great at doing that. We've had lots of practice on it. Same if I just give you a whole list of here's all these molecular things, name them or give me the formula. But then when I mix them all up together and there's some that are ionic and some that are molecular, well, that's when students really start to have an issue. So each and every time you see a compound, you're asking yourself this: is it ionic or is it molecular? So every time you look at a formula or a name of a compound, this is the question you have to say now. Is it ionic or is it molecular? How do I know if it's an ionic compound? Well, there's going to be a metal in it. So there's going to be an ion of some sort. So like sodium ions, okay? Or there's one polyatomic ion that is a cation. These guys are all cations because they're positive. Or maybe it's Fe3 plus, right? So all of these metal, this is a polyatomic ion. Ionic compounds have a metal, they're made of ions. Molecular compounds, that is not true. There are no metals in these guys, right? So if there's no metal, it's only non-metals. Those guys that are found on the right side of the staircase, okay? Guys like carbon and oxygen and then some of your diatomics, right? So there are no metals and there are no ions. These guys don't make ions. You're going to learn about how there is sharing of electrons to make molecules. So that's why it's O2 or Cl2 or P4. Those are diatomic or polyatomic molecules. So with your ionic compounds, I think you guys are getting the hang of this, right? Once you see the metal, you look up, does it have one charge or does it have more than one charge? So these guys like lithium and calcium and aluminum, just one charge on each of them. So you know they're univalent. You keep the name just the way it is. You write it exactly as it shows on your periodic table. If it's like this guy, copper or gold, you can see here that there's more than one charge there. And so you got to tell me which charge it is. These multivalent ones, you have to put the charge in brackets. So copper bracket 2, well, that's the Cu2 plus ion, not the copper 1 plus ion. Okay, and then of course, always looking at the endings of that second word. Is it chloride? Well, this guy is the element Cl. Chlorine becomes chloride. Or is it chlorite? Well, when I see an ITE ending like this or an ATE ending, I know I have to go to my polyatomic table at the top of my periodic table. If it's chlorate, well, that has a different chemical formula. Chlorate is ClO3 negative. Chlorite, totally different guy, ClO2 negative. So it's the number of oxygens that are going to be different. And that's why the ending is ATE or ITE or IDE. Okay, so pay attention. Careful reading for you guys. Okay, what else to talk about? So again, here's our rules for when we're naming molecular compounds. If there's an H in it or there's a one word only, so like this guy, glucose, well, that's just one word. I know that I have to look that up on the chart on page 3 of my data booklet. Or if I see, well, here's nitrogen, and oh, I know that is a non-metal. And here's hydrogen. Oh, he's got a hydrogen in him, and hydrogen, remember, it acts like a non-metal. Then I have to look him up on page 3. If there's no hydrogen in the compound, so here's an example, sulfur is a nonmetal, oxygen is a nonmetal, then I've got to use the prefixes to name it. So what I named this guy, I know the prefix for 1, so this is S1O2. That's what it means, SO2. So do I call this monosulfur dioxide? 2 is di, I'll look that up here. Is this the correct name for this guy? Monosulfur dioxide? No, I don't use mono in front of that first word. Okay, I would just call him sulfur dioxide. And then don't forget there's a couple of these memorized ones to look at, right? Like my polyatomic, well, there's 4 phosphorus. I just call them phosphorus, P4. Cl2, well, that's one of my diatomics. I just name him chlorine. Okay, but it's only one element, right? He's not part of a compound. He's just on his own as an element. Those are the memorized ones. So a lot of students didn't read too carefully, right? When I'm giving you a list of ionic and molecular compounds and I'm asking you only for molecular, don't pick any ionic ones, right? You can't pick gold, that's a metal. Don't pick potassium, that's a metal. So you have to read carefully. Don't pick any of the guys with metals. When we're looking for molecular, it's only non-metal and non-metal pairings. Okay, so a lot of students made mistakes and they got penalized. This was a summative and they didn't read carefully. Same here. Here's another example. When I'm asking you for an ionic compound, well, we only want the ones with metals. So nitrogen, that's a non-metal. Hydrogen, non-metal. Glucose, one word wonder, non-metals. Those are all molecular, so you can't pick those guys. So the next thing, now that I've selected a bunch of ionic compounds. So I've got beryllium, tungsten, silver, lead, and cesium. Which guy is different here? Which guy is different? They're all metals. Which one is different? This guy, lead. He has 2 different ion charges. He's what we call a multivalent. The question's asking you for a univalent. This guy is not included. Univalent, 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 univalent. Only one charge. Okay, so please read carefully. That is going to save you in the long run. Make sure that you are being cautious. Okay, so careful reading, right? Univalent, multivalent. How do I know? By looking at the formula that something's multivalent? Well, it has this number in brackets, and the number is the charge on that ion. Okay, and then again, looking at the endings very carefully, am I talking about chlorate or chlorite or chloride? Okay, so is it one of those ones on the polyatomic table, or is it just a regular non-metal atom that has become an ion? Okay, so again, memorizing diatomics, etc. And here was another one that students had trouble with, right? So again, reading carefully. Is it going to be a 2+ charge, a 1+ charge, a 3+ charge, and you have to look at the anion to determine that. And again, you're going to the polyatomic table when it's phosphate ion. And our golden rule is that the positives and negatives have to match up and add up to 0 when we are making compounds. So this week we are going to be learning about properties of ionic and molecular compounds. So molecular compounds, also known as covalent compounds, are made of molecules. And why is that? Because they share electrons. They each are going to hold on to the electrons. That's different than an ionic compound. The metal loses an electron to become a positive, a cation, and the nonmetal gains an electron to become a negative, an anion. So there's a transfer. They're not sharing, they're not holding them together. One guy is gaining and one guy is losing. Okay, and so you'll read about some other properties like melting point and how hard substances are. And then we'll talk about solubility this week. So if I'm going to dissolve something, let's say I have some barium chloride and I've got a little spoonful of barium chloride and it's a solid, right? And I'm going to dump it in some water and then I'm going to stir it and I'm going to look and see, is it going to become aqueous? Does it dissolve in water and it goes clear and I can't see it anymore? Or is it only slightly soluble? It doesn't dissolve and it just stays a solid clump. Which one is it? So to do that, I use my solubility table for ionic compounds. And this is in my data booklet. Okay, so I've got this barium chloride. I always start by looking at the anions. So the anions are listed up here. Here's chloride. Now I look for barium. Okay, I don't see him. Well, most things are soluble. That's not barium, that's not barium, that's not barium, that's not barium. So he's not slightly soluble. He must be like most guys, he's very soluble. So he's not going to be a solid like this. He's going to break up into solution, and I would write aqueous as his state. Okay, so that's about it for this week. We've got some naming acids and bases to do. You guys have the rules listed for you guys in your data booklet, and there are some videos to watch on that. So now we've got ionic, molecular acids and bases, and you will have 2 assignments this week, a formative. I'm going to get that back to you for feedback. And then you have a little bit later this week to finish up your second assignment because we have no school on Friday or Monday. So everybody have a good week. Email me if you have any questions. And until then, talk later.